we look at question 9. So our question 9 here, they ask us to evaluate limit for x approaches infinity for our function involving cert. And then our first attention will be we try to substitute our infinity inside our function. So infinity plus 1, it will get you infinity. Okay, a big number plus 1, so infinity actually. So when you do up there, numerator part, when you have infinity square and then plus infinity and then minus 1, then square root infinity, of course there's still, the operation still cannot get to the smaller value, it still will get infinity. So for this situation, infinity over infinity, our IDF form. So what we can do here is we simplify our function by divide the x power from cert function. So this is our special case from the cert function here. You can see in our cert function here, the highest power here is x squared. So means that we are going to divide this function by square root x squared. So once we divide our function of square root x squared, so outside here, denominator part, we will divide it by modulus x. So modulus x, then we have to consider whether it is positive x for x greater equals to 0 or negative x for x less than 0. So as we can see here, when we have square root 4x squared plus 2x minus 1, divide by square root x squared, so we can make the square root together, and 4x squared divide x squared. Divide independently. 2x, x divided by x squared. Negative 1 divided by x squared. So over, for denominator part, for linear function here, we won't take the format of square root x squared. We will take the simplified function that we want to choose here is positive x. As we can see, our x is approaches infinity, means our x is greater than 0. So we will choose positive x. So for x here, we divide by positive x. Then we're going to simplify our function. It will be 4, then plus 2 over x, then minus 1 over x squared, and then over 1 over x. Then we try to substitute our infinity. It will be 4 plus 0 minus 0 over 1 plus 0. So it will equals to answer of 2. So what is important here, we can see our concept of divide by x squared under the cert, and then divide by x for the function without cert. Then we evaluate, we simplify it to get to the answer. Okay, we continue for part 2. Limit infinity also. So we substitute infinity here, infinity over infinity. We still have a IDF form. So at the same concept like part 1, we will divide, follow our priority, go for our cert function. As we have cert x squared, so instead we will divide by cert x squared. So for others function, we will divide by modulus. Choose a suitable function. X for x greater equals to 0, negative x for x less than 0. So for our questions here, limit when x approaches positive infinity. So our 2, we will divide by positive infinity, we will choose positive x. Because positive infinity, it is greater than 0. So under the cert function, we will choose square root of x squared. We will maintain the format of square root so that we can divide inside our square root together. So it will be x squared divided by x squared minus 5 over x squared. So outside here, denominator without cert function, we divide by the simplest form of from this square root of x squared, which is x. Then we simplify it. And then we can try substitute our infinity inside. So 2 over infinity minus square root 1 minus 5 over infinity, and then 1 plus 3 over infinity. So what can we get here? It will be 0 minus 1, then over 1. So we can get our answer equals to -1. So our concept here, it will be division of our x squared under our cert, but outside the cert, you'll notice that you have to divide by x. So that will be another concept. Then we evaluate our answer, evaluate our answer to get this limit infinity equals to -1. So for part B, they ask us to find the limit of the function when x approaches 4. So we can see our function here. So limit for our function -5 over x minus 2 for x approaches 4. They give us an answer already equals to 1. So we want to find this limit for this function only. So for limit, we can do it independently one by one for the function. So we write it independently. For limit x approaches 4, it can do for fx at the same time minus limit approaches 4 for the function constant limit, and then limit for x approaches 4 for the linear function x minus 2. So we can find the limit independently in order to get it together. So this limit for the function when x approaches 4, this is the part we want to find it out. Then we simplify our part here as limit. This is the part that we want to find. So for limit to a constant, we will get 5 over when limit to a linear, we just substitute our value. So we substitute 4 here, it will become 4 minus 2. So finally, we simplify our limit x approaches 4 for the function. So it will equals to 1 times 2. Okay, move this value to the right hand side, 1 times 2, and then move the value of this 5 to the right hand side, plus 5, so it will give us a value of 7. So this is our first concept, finding our limit for corresponding function one by one, and then we simplify our limit for this limit constant and limit linear, limit function linear and limit function constant, then we get to the answer.